Well, without Rutherford, there would be no nuclear physics, or rather I should say nuclear physics wouldn't have developed when it did. I mean, he is the father of nuclear physics. There's no two ways about that.
Ernest Rutherford was born in rural New Zealand in 1871. He was a curious youth who embraced new technologies and was always keen to conduct his own experiments. At Canterbury College, his passion for research took him to the forefront of electrical science, winning him an 1851 scholarship and the opportunity to study abroad. Rutherford arrived at the Cavendish lab in Cambridge just in time to see J.J. Thomson discover the electron. The subatomic age had begun, and the young scholar from New Zealand was an immediate believer in the existence of objects smaller than atoms.
He was very sensitive to small effects and then didn't rest till he had understood them. He had the right attitude to do important work.
In 1898, Rutherford left Cambridge to take up his own professorship at McGill University in Montreal. He had one of the finest physics labs in the world at his disposal, and soon put it to work. There he discovered radon and atomic transmutation, and, with Frederick Soddy, mapped the chains by which one atom could transmute into another. 1904 also saw Rutherford first use radioactive decay to date the age of the Earth, a figure that had long been debated. With this work, he changed the foundations of science and won himself a Nobel Prize.
I mean, as soon as he discovered that atoms were not stable, it unleashed a mass of research and a mass of intellectual understanding of the structure of the atom and even the structure of the universe.
Rutherford returned to England in 1907 to head the physics department at Manchester University. Here, with the assistance of a talented research team, he conducted his famous gold foil experiments. Rutherford showed that the atom was mostly empty space, with all of its matter being contained in the small central nucleus. A new model of the atom was born, and the age of nuclear physics began. Rutherford spoke about his new discovery at the first ever Antipodean meeting of the British Association for the Advancement of Science. The event was hugely successful, although a little overshadowed. War had been declared in Europe. U-boats were wreaking havoc on British shipping, and the Admiralty desperately needed ways of detecting them. Professor Radium declared war on the U-boat. Rutherford's first secret report concluded that the only feasible means of detection was by the sounds they emitted, and that the best platform was another submerged submarine. In the basement of his lab, Rutherford developed and tested a unidirectional hydrophone. This was used by the fleet and secretly patented for the Admiralty. In 1919, the hectic war pace had eased, and he was able to find time to return to his own research. Ernest Rutherford triumphed again, splitting the atom and turning nitrogen atoms into oxygen. With this, he became the world's first successful alchemist.
Rutherford was a hands-on experimenter, and instead of watching what nature gave him, he tore it apart.
As a new decade dawned, Rutherford replaced J.J. Thomson as head of Cambridge's Cavendish lab. Thomson, the father of the electron, handed over to Rutherford, the father of the nucleus. It was the start of a golden age. The dawn of the big machines was imminent, and Rutherford would inspire a new generation of physicists to journey ever further into the atom. By now, Rutherford had a diverse team of researchers, both male and female, even though Cambridge University refused to give full degrees to women.
There were a number of men that supported women very, very strongly, and Rutherford was certainly one of them.
He was the most cheerful person, imaginable, and friendly too.
Throughout the 1920s, honours continued to flow to Rutherford. In December of 1928, Gamow sent Rutherford a manuscript showing that particles could tunnel into a nucleus. Artificial disintegration was now within reach, and Rutherford immediately gave his approval for Cockcroft and Ernest Walton to construct a proton accelerator. With Rutherford at the helm, the Cavendish lab was marching towards the age of high-energy physics, but it wouldn't happen overnight.
And it really took my father and Cockcroft's 4 years of their effort to get the accelerator, you would say electronics, up and running.
For the first time ever, a nuclear reaction had been induced by completely artificial means. By this time, the winds of change were blowing in Europe, and talk would soon become dominated by politics. Rutherford was outraged at Hitler's treatment of scientific colleagues, many of whom he knew personally. By 1933, Rutherford had helped found and become president of the Academic Assistance Council.
This was an organisation to help refugee academics.
Despite his balanced lifestyle, the 66-year-old Rutherford was troubled by a hernia. In October 1937, it caused him to be sick, and he was admitted to the Evelyn nursing home. 8 hours passed before a suitably titled surgeon arrived and performed the operation. It was too late.
He inspired very deep affection as well as tremendous admiration.
From Russia, Kapitsa wrote,
"All these years I lived with the hope that I should see him again, and now this hope is gone. I loved Rutherford. I learned a great deal from Rutherford, not physics, but how to do physics."
We've come a long way from the things that Rutherford studied, but in a sense the questions are the same, and the opportunities for someone like Rutherford to come along and really make those discoveries that enable us to understand our universe better are the same today as they were in his day.